Hello guys, welcome back to my channel MNR KRISHNA. In previous assignments, for the fourth assignment, the answers which are given by me all are all correct, but unfortunately, for the fifth assignment, two are got wrong. But we are using the same technique which are used for next further question also. Those are the correct, but these two are wrong. So I think something may be wrong by me, or I don't know that. Then I'm asking you for submit your feedback as to recheck the answers for those questions. Please do that. And today I'm giving you the answers for sixth assignment. Before going to video, please subscribe my channel and support me. Thank you guys. Thank you for your support. This is the sixth assignment. Here in this assignment, I am sure about the first four questions, but I am not sure about the next four questions. Those are fifth to eighth questions. First question: consider the following three Verilog modules that realizes D flip-flop and T flip-flop on 4-bit triple carry counter. Here the three codes for the D flip-flop. Here module DFF named as DFF, and for the T flip-flop named as module TFF. For 4-bit triple carry adder named as 4-bit underscore triple underscore counter. It is a code for 4-bit triple counter. We have the 4-bit triple counter as up counter, which is told by our instructor. Next, first question: assuming that all the T inputs of T flip-flops are tied to 1 and the remaining 3 unknowns are correct. Okay, the Verilog code implements a 4-bit triple carry down counter. All zeros represents LSBs and 3s represents MSBs if unknown 1 is equals to. Here we are using for triple carry counter, we using 4 T flip-flops. For 4 T flip-flops, we are applying 1 as the input to T, that is high. For toggling purpose, we have to apply 1 to T flip-flop for getting a counter. And then 3 unknowns are correct. Let us assume that 3 unknowns are correct. That is unknown 2, unknown 3, unknown 4 are correct. For first flip-flop, what is the unknown 1? Here T flip-flop, Q0 is the output and T0 is the data, and unknown 1 is the clock pulse of the flip-flop. For TFF0, what is the unknown 1? That is, what is the clock pulse to apply to that flip-flop? We have to find that. Let's go to the PDF. It is the 4-bit triple counter, that to up counter. It is a 4-bit triple up counter, asynchronous counter. For this is the logic diagram. Here the clock pulses is applied to the LSB bit, that is Q0, flip-flop 0, and the output of flip-flop 0 is given as clock to the next flip-flop, that is FF1. Like that we are getting the output as Q3, Q2, Q1, Q0. That is here Q0 is the LSB, least significant bit, and Q3 is the most significant bit. If you apply clock as 0, the output of this circuit is 0, 0, 0, 0. For the first clock apply, here first flip-flop will be toggled, so Q0 is 1, but remaining 3 are no change, not affected by that clock pulse. And then for clock input as 2, second clock input, here second clock input 1 will be toggled as 0. So Q0 0 and Q1 will be here. Q1 is depends upon the Q0, that Q1 changes when and only when Q0 changes from 1 and 2. It is the logic for up counter, that is whenever Q0 changes from 1 to 0, the Q1 will be changed. So here Q0 is changed from 1 to 0 for in clock input 2. So Q1 will be changed, that is from 0 to 1, and Q2 Q3 will be not affected because Q1 is not changing from 1 to 0. So no change is here. For clock 3, the first flip flop will be toggled. So Q0 is 0 to 1, and then here no change. Here Q0 is not changing from 1 to 0, so no change here at Q1. So 1 will be same as 1. Q2 is also 0. Q3 is also same. Like this, the process will be continued for the remaining counters. For given question, we have only down counter. So for the down counter, we have two ways to represent the down counter as a logic diagram. That is by taking the output as Q bar. That is for the first flip flop, we are taking output as Q0 bar replaced by Q0. Like that, we have the down counter logic. If we clock 0, for the clock 0, the outputs all are 1. So for clock input 1, the toggle is done. So for down counter, the logic is whenever Q0 changes from 0 to 1, the Q1 will be changed. The reverse process will be done for the down counter. It is one of the way to represent the down counter. We have another way, that is by taking the output as Q0 as like that same up counter, but clock pulse is changed. That is Q0 bar is given to the next flip flop as clock pulse, and Q1 bar is given to the in clock pulses of T2, like that. Here we changing the clock signals, or by taking the output as Q0 bar. Regarding to the question, the output will be taken as Q0, Q1, Q2, Q3. So we have to select the second way, that is by changing the clock signal. So for first flip flop, the clock signal is clock. So option B is the correct. Basic clock. It is an asynchronous counter. So, and assuming that the T inputs of T flip flops are tied to 1 and the remaining 3 unknowns are correct, the Verilog code implements a 4-bit triple carry down counter. Same question. If unknown, what is the unknown 2? Here unknown 2 for T1 flip flop, that is TFF1. For the TFF1, the clock is Q0 bar. So second option B is correct. Q0 bar, option B. And that next question, what is the unknown 3? For unknown 3, Q1 bar, C. For the next question, what is the unknown 4? Unknown 4 for unknown 4 is nothing but Q2 bar, that is C. So move to the next question. For 5th to 8th questions, consider the design and implementation of a sequential circuit with 2 GHz. Guys, I'm not sure about these 4 questions because I'm little but confused. So I am giving the answers from my end, but not sure. Please make your own answers instead of copying this 4. But above 4 questions, I'm sure about that, because they are easy to understand. For these 4 questions, I have just little but confused. So this is the same code which is given to the lecture video, that is, I think it may be serial count. This is sequence detector. The given code for the assignment, which is given in assignment, the code is like that, seems like that sequence detector. That is, it is, here is the code. Here is the Verilog code for JK flip-flop and Verilog code for sequence detector. They is same as, but slight changes there. Those are, think, here for JK flip-flop code, for JK flip-flop code, the same is done for in module also, but in the sequential circuit code, small changes occurred. Those are, here the outputs are taken 2 registers, those are A and B. In the given code, we have output registers only. Y is taken as an output register by the Q0 and Q1. Okay, here Y is nothing but Q1, Q0, and operation is done between the 2 output JK flip-flop, 2 outputs of the JK flip-flop, Q1 into Q1 and operation with Q0. Then we have Y output. In the question, 2 registers are taken as an output. Those 2 are, I think, Q1 is A, Q0 is B, or it may be Q0 is A, Q1 may be B. By this logic, we have 2 answers for each question. By assuming that, so if we assume that Q0 as A and Q1 as B, the answers will be changed different, will be different to the assuming the Q0 is as B and Q1 as A. But according to question, I think here outputs of A and B are 2 inputs E and F. Here inputs also 2. We have 2 inputs, but in that code we have only one output, that is one input, that is X. Here if E is equals 0, the circuit remains in same state. Here represents if E is equals 0, that remains same state, no change will occur. If E is equals to 1, the outputs may be changed, that is depends upon the value of F. If F is equals to 1, the transitions may be from 0 to 0 1 and 1 0 and 2 1 1. It is like that right shift. If E and F are 1, inputs are 1 high, the operation is done, is that right shift operation. And if E is equals to 1 and F is equals to 0, the circuit goes through the state transitions from 0 0 0 to 1 1. Okay, this is a left shift, I think. So here you have to use a multiplexer also, I think maybe. For the 5th question, assuming the other 3 unknowns are correct, okay, the correct Boolean expression for unknown 1 is, I think for this, if I consider JA. If I consider it JA as J1 and JB as J0, the outputs are unknown. One is here. By observing the question, E is common, so the operation is depends upon the F only. If F is equals to 1, the right shift operation will be done. If F is equals to 0, the left shift operation will be done. So for this, we have to confirm that to operation these two processes, first of all, E will be high. Then we have to compare the two inputs by using XOR operation or XNOR operation. Those are in XOR operation. By using using of XOR operation, if two inputs are different, the output will be 1. In XNOR operation, two inputs are different, the output will be 0. These two gates are used as comparison purpose. So for this, here JA means, here this is the code. Let us assume JA means Q0, so JA means J0, K0 means KA, J1 means JB, K1 means KB. Then clock and X are the inputs. In given code, X is not the input. Here E and F are the inputs and output are two registers are output. So assign J0 means JA, I think JA is equals to X. So like this logic J0 so J0 means JA is equals to X, but by assuming the Q1 as A, that is J1 as A, J2 as B, the outputs will be changed. So I'm not sure about these questions, and just follow the sequence by comparing the two codes. That is here J0 is the first, so in this question JA is first, so I just equating that the two values. So J0 is equals to JA. For J0, as in given equation, X will be available. For X means E. So for fifth question, E will be the answer. And for the sixth question, unknown 2. Unknown 2 means Ka means K0, I think K0. For K0, output is not operation between X and Q. So X and Q not operation means X not, I think, by just replacing. For J1, here only the XOR operation, it means here the NOT gate is used here, so I think it is XNOR operation. So for KA, the output will be XNOR. XNOR means option B, BF plus B bar F to A, where B represents complement of B. Then seventh question, what is unknown 3? For unknown 3, JB means J1. Okay. For J1, the output is AND operation here, but in case of this question, XOR operation. XOR operation means BF bar plus B bar F into A, where B represents complement of B. For the eighth question, Assuming that the other three unknowns are correct, the correct Boolean expression for unknown 4 is 4 unknown 4 KB. KB means we are assuming that KB means 1. So K0, K1. Sorry. What is the K1 here? K1 means X bar. What is the X? X is nothing but E. So E bar is the answer. E bar is okay. That's it, guys. These 4 questions may be wrong or right. If any one of the question is wrong, the 4 questions will be wrong. The same logic which is using in 5th question is followed by the remaining 3 questions. So if one question will be wrong, all other also wrong. That's it, guys. But for first 4 questions it may be correct. Let's hope for the best, guys. I think it is very useful to you and me. In yesterday, in previous assignments also, this platform is very used and useful. It is very used to discuss the topics or doubts. So many are helping me to clear the confusion. So many are make me confusion also. That's it. If you found any wrong, please comment in comment section, or please do that, guys. For 5 to 8 questions, make your own answers and give me that answers in comment section. I have to refer that. I'm also appreciating you. Sorry for the late updation. Remaining 2 assignments only for this course available. That's it, guys. Please do your own assignment. Thank you guys. Please subscribe my channel and support me.